Nissan showed production without people and said that soon all the company's plants will be just like that. Should people be afraid of losing their jobs? And what else can we expect from Industry 4.0 in the near future? Well, in today's episode, Nissan showed production without people. All the work is done by robots. Basically, we have seen this before. For example, Elon Musk tried to remove people from production at his factory in Fremont, but then was forced to admit that people are undervalued. Even earlier, in the mid-80s, Steve Jobs decided to produce computers in a robot factory and even started it up. But PC component sizes were changing at an incredible rate, and reconfiguring the factory was slow and expensive. Eventually, the factory closed. So how is Nissan's manufacturing any different from past experiences? The Nissan Intelligent Factory production line is not just as robotic as possible. The main feature of the factory is that humans no longer make any adjustments to production. The robots themselves do that, equipped with artificial intelligence. They independently analyze the data they receive and can assemble all three types of Nissan vehicle models without any readjustment, with internal combustion engines, electric or hybrid. As each vehicle moves down the assembly line, it's equipped with the right powertrain. Also, the process is streamlined. For example, a new type of paint allows the car bodies and bumpers to be painted and baked at the exact same time, reducing energy consumption by 25%. The carbon footprint of the new plant has been minimized. The company assures that similar innovations will gradually be introduced at other plants around the world. However, there are still few people at the factory, and they analyze the data collected by the robots and also engage in the maintenance of the equipment. Previously, the biggest problem of robotic factories was considered a lack of flexibility, and only humans could boast a quick retraining, requalification, and the ability to adapt to these changing conditions. But what about now? Well, Industry 4.0, or the Fourth Industrial Revolution, has already happened, and we haven't even noticed. Well, it almost has. And here are the main reasons and trends that have changed the manufacturing and labor market. The first reason is the development of artificial intelligence to the point where projects with it become commercially successful. Advanced AI enables preventative maintenance, cognitive computing, swarm intelligence, context-aware computing, generative design, and more. For example, startup Mechanica AI offers industry-grade AI capable of integrating with legacy assets and using imperfect manufacturing data to make autonomous decisions. By integrating industry knowledge into artificial intelligence, the company is developing a universal AI model that is accessible and useful to any enterprise. The second catalyst for Industry 4.0 is digital twins and performance verification modeling. Now, you don't have to do anything in reality to make sure that complex robot software is correct, or even an entire factory is built correctly. It's enough to create a digital twin and use it to test all the technologies and processes in a simulated environment. Additionally, the production can be quickly adapted to any changes, creating a digital twin that's able to independently monitor variables and optimize them real time. The third trend of Industry 4.0 is additive manufacturing. Originating as a rapid prototyping technology, 3D printing is revolutionizing manufacturing, making it easier to produce complex parts. Advances in material science, stereolithography, and 3D metal printing are pushing the boundaries of offline production. The technology has already reached the micrometer scale of printing. For example, the Swiss startup Exato is developing the Series system, which allows printing complex metal objects ranging in size from 1 to 1,000 micrometers. But the more technology advanced and autonomous in the production, the more individual and delicate its settings are, the more acute the issue of privacy and cybersecurity is. But there's new technologies being developed right now to ensure the safety. Self-adaptive security, zero-trust security, and end-to-end communication security, DevSecOps, and blockchain are just some of the new developments in this direction. Another example is the robot immune system being developed by the Spanish startup Alias Robotics. This platform protects robots and their components from malware and offers a secure data logger to investigate cyber attacks or robot failures. Another startup, Autolus, is developing FACT, a system that secures software updates for all factory devices. It collects unique file fingerprints from hardware vendors and compares them with those obtained by manufacturers. Fact gives a credibility assessment during the installation of the update on different manufacturers' equipment. But technology isn't just pumping up robots, it's also pumping up humans. Wearable exoskeletons enhance workers' physical strength and endurance. Of course, even with them, people won't be able to work 24/7 like a robot, but we are more versatile and flexible. So, maybe we still have a chance to compete with robots for jobs. The second technology coming our way to help us compete for robot jobs in factories is the future XR technology. They include mixed reality, augmented reality, and virtual reality. They are mostly used for research and development, but they can also be part of an intuitive machine control interface or a full-scale manufacturing and post-production process. Robots can also play on the side of humans, especially if they are cobots, machines designed specifically to work alongside humans and not replace them. Cobots make human tasks more efficient. They are easy to set up, they're flexible and inexpensive when compared to other robots. Yet, they can be accurate to 0.1 millimeters and carry small loads on the order of 5 kilograms over short distances up to 1 to 1.5 meters. But despite the high expectations that have been placed on robots over the last couple years, they still haven't flooded the planet yet. In general, robotics is evolving. The industrial robots in manufacturing, logistic robots in warehouses, collaborative automated systems, humanoid robots, and robot grippers that can work with any object. All of this brings together the Internet of Everything. This is also the trend of Industry 4.0, which includes real-time machine-to-machine, human-to-machine, and human-to-human communication. This is the industrial Internet of Things, Internet of Skills, Internet of Services, Internet of Systems, and Internet of Things on the shop, and Internet of Things on the shop floor. The Internet of Everything combines real-time data, machine intelligence, and human skills, resulting in faster, more efficient, and cost-effective manufacturing processes. And we want to believe that this will be the manufacturing of the future, where human ingenuity, experience, and creative thinking will complement the physical strength and precision of intelligent robots that are responsible to the commands of their living masters. What do you think the future will look like? Let us know in the comments. And while you're here, subscribe to the Pro Robot channel and don't miss any new episodes from the world of high tech.